An intercept is a point where the graph of an equation touches a particular axis. And for now, we're really just going to talk about the x and y axes. So let's draw out the coordinate plane and draw a line. Alright, so let's say this is some algebra equation. Now let's find, we'll label our axes. Alright, so we're talking about intercepts. Where would the intercept be of the x-axis? You can say right here. So this is the point where the graph crosses, it touches. It doesn't necessarily have to cross it, it just has to touch it. As soon as it touches the x-axis, it's intercepting the x-axis. And we can say the same thing for this point as far as the y-axis. So this is the point where the graph intercepts the y-axis. And now that we know where they are, we want to find out what they are. So let's say I have an arbitrary equation. Y is equal to x plus c. And c can be any number. It can be 1, 2, 3, 4, 5. It's not that important. So if I want to figure out what this point is, and I have an equation, how am I going to go about doing that? So if I want to do that, let me think about what I do know about this. I don't know how far over on the x-axis this is. I have no idea what its x value is. But I do know one thing. I know what its y value is. At this particular point, when it's on the x-axis, its y value is equal to 0. Because it has no vertical value. It's not. So all along this line, y is equal to 0, as we know from studying the coordinate planes. So now that I have that piece of information, what I can do is, if I have an equation like this, I can put 0 in for y. And what happens is I can eliminate one variable. So I have 0 is equal to x plus c. And c is just some constant. It's any number for now, until we choose a particular problem. But now that I only have one variable, I can solve for x, so I can figure out what the x coordinate will be. So I know what the y coordinate is, but I don't know what the x coordinate is. So the y coordinate at this point always has to be 0. And the same thing can be said for the y-intercept. So for the y-intercept, I don't know what the y value is, but if it's on the y-axis, that means x has to be 0. So for this case, I can put in 0 for x, and then I get y is equal to c, so whatever that is. And then I have an ordered pair once I solve for whatever the rest of the equation is. So that's how we find out what the intercepts are, because we take advantage of the fact that since it's touching the x-axis, we know all y values are 0 at the x-axis. And then for the other one, since it's touching the y-axis, we know that the x value has to be 0. So now that we know how to solve these problems, let's do a simple one. Let's do y is equal to 2x plus 3. So we're going to look, we want to know what the x-intercept is, and we want to know what the y-intercept is. And again, so we have this equation. How do we find that? Again, we have to think to what we're looking for. So let's do the x-intercept first. So the x-intercept, we don't know what the x value is for here, but we know the y value is going to be 0. So again, we put in 0. So we're going to solve for the x-intercept first. So number 1, number 2. So when the graph crosses the x-axis, we know y is equal to 0. So we put in 0 for y. And now it's a very basic algebra problem. We subtract 3 over to the other side. Then we divide by 2. And then we have x is equal to negative 3 halves. So negative 3 halves. Now let me just cross this out so we don't get confused. So now we want to solve for the y-intercept. And again, we don't know what the y value is, but we know when this graph crosses the y-axis, x will be 0 at that point. Because again, there's no horizontal value. It is 0. So now, do y is equal to 2 times 0 plus 3. And that just leaves us with y is equal to 3. So the y-intercept, the point at which this graph crosses the y-axis, is 3. And really the best thing, in my opinion, about the intercept, about finding the intercepts, is that it's a real easy way to graph a line. Because for a line, all you need is 2 points. So actually, let's graph this equation because it is a line. So here's our graph. 1, 2, 3, 4. Alright, so now we put on our 2 points and we'll be done. So our x-intercept is negative 3 halves. So here's 1 and a half. So there we go. It's minus 3 halves, and then it crosses the y-axis at 3. So we go up 1, 2, 3. And those are our intercepts, and that's all we're looking for, but I just want to demonstrate how we would turn this into a graph. Well, that's not a very straight line, but you would just connect these 2 points, and then this would be the graph of your line. So calculating the zeros is, the intercepts really is going to be one of the more practically useful things you'll learn in this class. It's applicable to a lot of different fields of math, and you'll be using it all the time in sections to come. And also, it's the only method I use to graph lines. It's very fast. It's really easy. You just get your 2 points, and it's real simple to label. Sometimes actually you'll be counting some arbitrary points out here, and you'll end up putting them in the wrong spot. But with this method, you get 1 point on the x-axis and 1 point on the y-axis, and then you're done. So it's a really great method for graphing lines.